We got asked to kind of fill in. So I'm Greg Maxwell, and I'm leading the group with the Sample Robot Return Challenge. So this is kind of an overview of what we've done to this point. And so what we'll do is I'll kind of go over and talk about what we're doing, and then I'll have a presentation on each kind of technology we have. And so pretty much we're planning on basically picking up this little object you see holding in the robot's hand on the left side. We call it a pre-cache sample, or basically a sample. And it's kind of the challenge is to pick this piece of plastic up, and there's a couple around the room you'll see. And pretty much the idea is that you go out, find this thing in the field, bring it back, and land it on a platform, and then you get to go to the next level. So the challenge is outdoors, and it's basically an outdoor search. Locate something, pick it up, and return it. It's an 80,000 square meter area, like a park, and the technology we'll be using is pretty much visual, because there's not much else you have available to you. One of the aspects of the contest is that it's supposed to be on the moon or on Mars or someplace, so there's no magnetics, there's no atmosphere, there's nothing you can use with like ultrasound or sound. So you have some sort of limitations. They don't allow open air pneumatics, and they test you, and they're somewhat strict. They say throughout the rules, you can be disqualified for this, disqualified for that. Contest is June 8th through 13th. It's 7 months away. It's pretty soon for us to kind of do this type of thing. It's in Worcester Polytechnic Institution in Massachusetts, and this thing is hard. Later on, you'll get a kind of an overview of other people who've attempted this challenge and how they've done. But to give you a quick overview, for 3 years running, for the level 1 attempt, there have been 39 attempts, only one succeeded. And these are not slack teams, so this is something's going on that makes this hard. There was one level 2, which is the run for the money, and they didn't even start. So to give you an idea, here are pro teams. This is what they've been doing for quite a while, and they can't even get off the platform. So it definitely has its challenge. All right. So to find out more about the SRR, I put the slide together. I'll have it again up at the end. But if you look at, it's at WP, I guess, for WordPress, at WPI Education. The challenge, if you just search for NASA Sample Return Robot Challenge, you get back a lot of results. YouTube has a lot of videos about this, and they're somewhat entertaining. NASA's put together a few. I was going to kind of dice them up and show you these disasters of smoking robots and robots flipping over or running into the fence, but time doesn't quite allow it. Also, you can join our SV Ross user group, which is a meetup, and we're pretty versed in what's going on. Or you can reach out to me. Again, Greg Maxwell, there's my email up there. Team is called Maxed Out. That's just a term my wife came up with. So we have 27 members right now. We meet every other Monday, and we've got a pretty impressive list of talent. We pretty much started less than 2 months ago, and we've already got the visual challenge aspect of this, we think, done. So we can go find the sample pretty much out in the open field and go gather it. Our goal is to achieve level 2 runs in May, a month before we have to actually go do it. Our mission statement is, again, from JFK. We do it because it's hard, but we're going to rise up, and we're going to do something great. And I think it's a group of this size that we're able to achieve this type of ability, and the talent is amazing that we've gathered so far. Kind of the concept of Maxed Out and our kind of grouped recipe for success is 95% is the software. We are not even playing with hardware right now. We do a little bit. But the idea is that if we can't solve the problem, to have a logical search, to have a program that can then take the images and determine if the object's there and then guide our test vehicle and software to that object, why bother? Why continue on? It costs money, it takes energy, it takes effort. If we can't do the simplest part of this and do something in a very, kind of strategic way, why continue? So it's only after the software works do we continue on. And then after that, we determine, what the sensors and the hardware is going to be, and that kind of determines the power and the size of the chassis and everything like that. We are planning on using Ross Hydro, using Ubuntu 14.4. We're going to use the Jetson TK board, so we can have some GPU availability, so we can do a little more visual processing on the computer, and then Ubuntu laptops. Our main kind of process is to keep it simple, which is really hard to do, you can imagine, as it gets more and more complex. As you'll see, I've got a camera LiDAR system in the back, and it doesn't have any cables on it yet. Looks pretty elegant, but once you start throwing the cables on, it goes all out the window. So next month, when I bring it back when it's fired up and working, you'll see the difference and how hard it is to keep it simple. And then also, we're trying to keep it open so that new ideas and new people can always show up and help us do our, to achieve our goals. We aren't, we want people to understand this is hard, we need help. So, okay, so in 2 months we've covered a lot. So these are the presentations that are going to come up. Steve, are you ready? So Steve is going to do kind of analysis of what's going on, what's happened in the past. And then Alan's going to be how we're going to be successful. And then Patrick has a very good spiel on object detection, which is what the key part of this is. And then we've got a couple people with how we're picking things up. And then we've got some test beds that we're going to kind of show you what's going on. All right?
My first portion is talk about the sample return robot challenge competitors and some of the difficulties that people have seen. Competitors are for both domestic as well as international. There's teams from high schools, literally mother and father teams. There's a couple teams like that, as well as some of the teams have PhDs, a team of PhDs, a team of people that were working on the PhD, and this was part of their thesis. Some of the vehicles were very high performance. They were able to track down, identify parts, much like this. A few even picked up and grabbed the sample, and one even was able to return to the home base. My estimate on what people were spending was somewhere between $20K for the low end, and probably $80 to $100K for some high-end machines. So that include the labor, and you get some pretty high prices. Some of them are extremely well engineered. Oops.
Microphone.
Yes.
There's a microphone on the table.
The table? Okay. Can you hear me?
Yeah.
Okay. So what you can see here is the LiDAR that Greg talked about. This goes and maps the area it's in. And this is one from University of Waterloo. I like this one in particular. They did a lot of good work. And the way it works is you can see the target over here. Visual Systems identifies it, comes up to it, and they have this big gripper that comes down, grabs it, raises up, and then this slide rotates over and drops it down into a like a conveyor underneath the robot. So it just drops it in, trying to simplify the problem with that. Since GPS and compasses are now allowed, many teams have to rely on the LiDAR and the optical recognition. So this is one of the nicer ones. There was a couple that were really outstanding. This is one I mentioned from Ma and Pa, literally husband and wife team. Clearly enjoyed the process of making it, and they had their own Go Bear on it, and it went off and did not find a first sample. But you can tell from talking to them that they really enjoyed doing it. Other options were some people, instead of having one machine, they had multiple scouts. This team, I think, they started with 4 scouts. So you can see it has the claws, has the gripper, and the intention is to grab the sample and bring it back to the home base.
Who makes that robot?
This was Kulkagar. I think it was an Australian team, if I'm not mistaken. And if I remember right, they added on to an existing machine. You know what I mean? So they probably put the gripper on it, but I think this base was commercially available. And I see what looks like Python, but I can check it out, see if I have any information on it. Okay. Why is this so difficult? It looks pretty easy. Well, as Greg mentioned, it's meant to mimic what we might see on the moon or on Mars, and unlike other competitions, GPS and compass are out the door. Instead, LiDAR, gyroscopes, image processing to navigate. Now, one thing that we are given is topo maps and satellite images. So before the competition, we know where one of 3 spots where we're going to start. We know where the sample is. I may have that backwards. And we also have a topological map. And these are from 2 different years, but you get the idea. So you have a topo map. So if you were motivated to, you could get an altimeter and use that to help guide
What's
your
the distance there?
This was what, 200 feet, 203 feet, 300 feet from the first to the first cache.
Yeah, the field's approximately 800 meters by 100 meters.
But to the first sample, you could see it. You could see it.
70, 80 meters.
Sorry,
210 feet roughly.
210 feet.
Yeah, 70, 80 meters.
So you would think it's easy. Yeah, it's but it didn't. It hasn't worked out for anyone but one team.
Easy for you, Steve.
Okay. Any other questions about this?
Yeah. Just wanted to point out altimeters are verboten because that relies on atmospheric
Yeah,
pressure.
no altimeters.
Oh.
What do you know what the object looks like?
I would challenge you on that. I think you're able to use things that are relying on atmospheric pressure. You can't use air as a pump, but I've read the rule, and my interpretation of it is an altimeter is fair game. This would be a good question to ask, ask the NASA as to whether or not we can use it.
There's no atmosphere on the moon, pretty much. There's no atmosphere on the moon, pretty much. Period.
True, but unless they exclude it, I'd want to have it on the table. Things we might want to include. Currently, altimeters you can measure 20 centimeters. So here we're looking at I think it was about 20 feet, if I'm not mistaken. Yeah. So conceivably, it's something I might be able to help us out.
Where do people fail?
Segue. What a segue.
Did they tell you?
I've never seen you before, have I, sir?
Oh no!
Did they tell you what the object looks like?
What's that?
Did they tell you what the object looks like beforehand?
Let's see. Everyone knows this. There's 3 levels samples. The first level they give you pictures. There's a pink tennis ball and a bright orange. It's like a small piece of PCB. So there's three or
Steve,
more of them they do.
Let me help you out.
Sure.
So this is the first sample. You have to pick up, and in level 2 you have to pick it up again, and then they give a number of easy samples. Tennis balls.
Okay.
The pink. This is very much the tennis ball that they will use.
So you're looking for
very much the red puck that they will
Okay.
use.
You're looking for a white cylinder with a hook on it.
Yes, and it's exactly that shape and exactly those dimensions.
Okay.
However, these are low points, and these only get a point each. And to get into the money, which can get as high as $1.5 million, that's why this is worth doing. You have to get into some of the intermediate objects or the hard objects, and there they only give you descriptions, or they don't show you pictures or tell you where you can buy them. But one of the descriptions, for example, is a 3-inch wooden cube, so you know it's probably going to be wood color, and you know the dimensions, so things like that.
Yeah, and thank you, Patrick. And a couple others are some of the very high value ones. They effectively they say they're steel or they're metallic, non-ferrous metallic. And they have symbols on them, and you know what the symbols are. They provide the symbols. So in theory, you can go out looking for something that's metallic and has these symbols on it. But there's an intermediate group that what they do is when you show up for the competition, they have samples that you're allowed to look at from I think it's like 10 meters away, right? And you can look at them. What many teams would do is take pictures and try and put it into their libraries to recognize it, so when they go out in the field they can identify it. So, thank you. Thanks for the question. Okay, talk a bit about some of the results. let's see. Here's a summary of the results. I took the last 2 years. There were a total of 39. I don't see it there, but there were 33 plus 6, 39 attempts, and only 40%, 47% were able to power up and leave the platform. Right. So these are people that have been working on this for months. So, and only 5% of the trials were able to get the sample and return to the platform. In other words, 2 people. And only one of them was actually able to get back on the platform in the right place. So I'll just touch on a couple of these. Basically, here's the percentage that pass. It dwindles down. Couple didn't qualify. They showed up, paid the money, and they were disqualified at the beginning. Let's see, another 8 didn't get off the platform. 4 more got off the platform. One of them fell off, and others just kind of circled around and really didn't go very far. Another one had a design issue, and some of the more competitive ones, like 1 in 4, ran well, but they weren't able to find a sample, and others weren't quite able to get the sample and bring it back. And the second level, I'll just touch on quickly. It's been talked about already. Second level, the samples are placed over 80,000 square feet, which is huge.
Meters. That's even bigger.
Square meters. Thank you. And competitors are giving, like I mentioned earlier, pictures of the earlier samples, and some of the more difficult samples we get to take pictures of, like the day of, the day before competition. And this was mentioned, not a single sample from level 2 has been retrieved. And that even the original sample on level 2 wasn't achieved. Other problems that have been seen. About 36% of them didn't boot at all. Overwhelming largest problem is not being able to identify sample, which is why we're putting about 90% of our effort into being able to do that. And I understand that's solved, right, Country?
Yeah, right.
And large number of the competitors, barely got ready. Like realistically, from the time you decide to the time you accept it, and you start, you have maybe 6 months to get ready, and it's not too surprising how difficult that is. Just to get the machine up and running. A lot of people show up, and the software they just started working on it the previous week, and they worked hard. They want to be there, so get ready for the next year. In one case, even the robot picked up a sample, didn't identify it as a sample, and threw it back, and then started to look again. So we're not going to do that.
I hope we can do that.